Okay, so what I want to do in this video is I want to discuss the various different types of reaction. We are going to discuss the double replacement reaction. We are going to discuss the single replacement reaction. In addition, we'll take a look at redox, the oxidation reduction reactions. We'll take a look at combination in subsequent videos, and we'll also take a look at decomposition. So I want to give you some key highlights as to how one would be able to distinguish between a double replacement from a single replacement, and in a sense identify what kind of reaction we are talking about. So let's start with the double replacement first. Let's say you have a solution of sodium hydroxide, NaOH, and since I said it's a solution, that means it's going to be present in the aqueous form. What that means is that you take solid sodium hydroxide and you have dissolved it in water, so you have generated a solution of it. And let's say I react it with hydrochloric acid, HCl. Your products in this case are NaCl and water. I'm going to write water as HOH just for the sake of simplicity so you can see what's going on here. We have Na plus and OH minus as the participating ions for sodium hydroxide. We have H plus and Cl minus as participating ions for hydrochloric acid. And notice what happened. Essentially, chloride, which was earlier participating with H plus, has now started forming a bond with sodium to generate NaCl, and hydroxide that was earlier connected to sodium is now forming a bond with the proton from HCl. What does that mean? That means, don't you think, that the ionic partners, the chloride and OH negative, so two sets of ionic partners have been switched. So you can envision this perhaps similar to, let's say there's two couples that are participating in some kind of a dance show or something, and now they have switched their dancing partners, and so chloride reacts with Na plus, OH negative reacts with H plus and generates water. So just because there's two different kind of ionic partners that have been changed, we call this the double replacement reaction. Specifically, within the double replacement reaction, this kind of reaction is also going to be called as, or classified sometimes as, the acid-base neutralization. And the reason we call it acid-base neutralization is because a hydrochloric acid, which is acidic in nature, pH being less than 7, is reacting with sodium hydroxide, which is a base, pH being more than 7, to generate a salt and water. So this is acid, hydrochloric acid reacting with sodium hydroxide, but that's your base, combined to give you salt and water. So the formation of water is the driving force here, and that's the reason we are calling it acid-base neutralization reaction. There is another kind of double replacement reaction, which is the precipitation reaction. And as an example for that, I want to give you, let's say I have potassium iodide. Again, that's an aqueous. So anytime you write down the letters AQ in the subscript, recall that means you have a complete solution in your reaction mix. So it's clear, it's transparent, it will look just like water. There won't be any solid that would be floating in that solution. And now I'm treating that with, suppose, lead 2 nitrate. That too is in the aqueous form. So envision that you have two test tubes which have clear solutions. One contains lead 2 nitrate, the other contains potassium iodide. And if you were to do the exact same thing what you did right here, essentially switch two sets of ionic partners, you would see that you would get KNO3 and you would get PbI2. Now KNO3, since all nitrates and all salts of potassium are solutions,